so now we're going to go over the different ways that we the different conclusions that we came to, because not only can we say two triangles are congruent if all the sides and all the angles, but there are certain circumstances where we can say, all right, if I tell you that if I give you three sides of a triangle, there's only one triangle that can be created with those, so all triangles that have those three sides are congruent. So that's what we start with. We start with side, side, side. So if three sides, side, side, side just says if three sides of two triangles are congruent, there we go, then the triangles are congruent. And I like highlighting the sides that are the same. So here is congruent to here. Let's go. This one's congruent to this one. And lastly, this guy is congruent to this guy. And that's what side, side, side congruence looks like. Our next one, which was one of the ones that you investigated, just says, so we have side, angle, side. So if two sides and the included angle, and it has to be the included angle of two triangles are congruent, then the two triangles are congruent. So for this one, I know this side is congruent to this side. I know this side is congruent to this side, and the included angle of those sides, this one right here, those two are congruent. So the triangles must be congruent. Okay, next one is if two angles and the included side, if those were congruent, there was only one triangle you could create. So this side is congruent to this side. This angle here was congruent to this angle here, and this angle was congruent to this angle. It's going to be angle, side, angle, and so the triangles have to be congruent. The last one's a little bit more interesting because it's derived from this. Basically, so I have these two triangles here. I know for sure that this angle would have to be congruent to this angle by third angles theorem, so I know that these would actually be congruent because of angle, side, angle. That's why this one is actually called a theorem, because by itself, it's not, you actually are using angle, side, angle to prove that to be true. And if we were in class, I probably would have done things a little bit differently. So, but I'm gonna actually just delete that stuff. Okay. So for this one, it says if two angles and the non-included side of two triangles are congruent, then the triangles are congruent. So in this case, I know this side is congruent to this side. I know this angle is congruent to this angle, and this angle is congruent to this angle. So these two triangles are congruent by angle, angle, side. Okay. Last one is called hypotenuse leg theorem. And I'm going to just go through this. I'm just going to go through why this would be true. I think this is kind of interesting, especially for those of you that are kind of math people. So if I just told you that this was A, this was side B, this was side C, this side is D, this is E, and this is F, okay? And these are both right triangles. So you know Pythagorean theorem. You know that A squared plus B squared is equal to C squared. For the second triangle, you'll know that D squared plus E squared is equal to F squared. Now we know that E and F are, congruent to each other, so E squared must be equal to, C squared and F squared. I know C is congruent to F, sorry. So I know that C squared must be equal to F squared, okay? Which means that A squared plus B squared must be the same thing as D squared plus E squared. So I also know, kind of in the spirit of the other things, I also know that B is congruent to E, so I know that B squared must be equal to E squared. So I can actually subtract B squared and E squared from each side, and so my conclusion is, well, then A squared has to be equal to D squared. So basically, because of Pythagorean theorem, if the hypotenuse and leg of one triangle is congruent to the hypotenuse and leg of another triangle, another right triangle, of course, then the third sides must be congruent. So my conclusion is, well, then this side would have to be congruent to this side. So these triangles would be congruent by side, side, side. Okay, that's all I just wanted you to see, is that's the whole reason why this one works, is actually this is side, side, side in disguise. So I'm going to erase some of this. I'm actually, well, I don't want to erase the D. There we go. But what you really need to know with this is, if I know the hypotenuse of two right triangles are congruent, and the leg of two right triangles are congruent, then the triangles have to be congruent to each other. There's no other triangle. That third side would have to be the same. So if the hypotenuse and a leg of two triangles, the hypotenuse and leg of two right triangles, sorry about that, right triangles are congruent, then the triangles are congruent. So now we're going to go through and kind of use these. These are all the things that you can use to prove congruence, and we'll talk about the ones that can't. Just some side notes that I wanted to add that I didn't do it in the notes. There's no angle, angle, angle. Because the angles can be the same. But the sides can be different. And my other note is there's no SSA or ASS because there are multiple triangles that can be created with this. And we explored that yesterday. Okay, so we're just going to go through and we're going to see if these are congruent. So for this one here, I know HT is congruent to JR. I know TJ is congruent to HR, and they share a side. This is going to be called reflexive property. We'll go over that in a little bit. But since they share a side, we know that side's the same. This is going to be yes by side, 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 because we have three sides of one are congruent to the three sides of another. Okay. For this one, so we're just careful. I highlight the sides that are the same, blue and blue, orange and orange, and then the angles in between. This is an included angle. So we have two sides and an included angle. This is also two sides and an included angle. And so this is going to be yes, this is side, angle, side, because the angle's in between. For these, I'm looking at right triangles, and there's something very specific, okay? Because this right here, this would be a non-included angle. So this would be two sides and a non-included angle, which wouldn't be criteria. We know that there's no SSA or ASS. But since these are right triangles, they have Pythagorean theorem. So we have a leg is congruent to a leg. And we also have a hypotenuse is congruent to hypotenuse. So this is actually going to be yes by hypotenuse leg theorem. Okay. This one here, so this next one, they have those sides that are congruent. And we also have, they share a side, but the problem is, and this is going to be a no, is there's not enough info. And you don't have to write that. I just want that in your notes so you understand. For this one, the little stars and stuff like that, for this, they're the same, in the same spot. That means that they're congruent. So this little star and this little star means those angles are congruent. This X and this X means that those are congruent. And then this side and this side. And so this side right here is non-included, just so you know. And this side is also non-included but you have an angle, and so this is going to be, yes, this is angle, angle, side. Okay, and make sure you put that. It's not side angle, angle, it's angle, angle, side. This one here, so we have this angle and this angle. We have this one, this little star and this little star. And then we have this X and X. But this is angle, 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 and this is not A. So this is going to be no, not a way to prove congruence. Okay, because those triangles could actually be different sizes. So don't trust your eyes. This one here, so we have a side and a side. We have this side and this side. Okay, so we have two sides. And we also have an angle. Now you have to be really careful because you have to determine, is this ASS or SSA or is this SAS, okay? And so I'm looking at this. These are non-included. So this would be SSA or ASS, okay? And so no, that's not a way to prove congruence. So this would be a no. You wouldn't write this. It's just, I'm just spelling it out with the letters. For this one, again, you kind of see that there are only two parts, but you realize there is something else that you need to know. And we'll do more of this next class. But this angle is congruent to this angle. So this is going to be yes by side, angle, side. And this last one, we have a side and a side. So we do have three things and three things, which is good. We have this side and this side. And we have this little angle here and this little angle here. This one here, this angle is included, so that would be okay. This would be SAS, but this angle right here is not included. So this is going to be, this would be ASS or SSA, and so this is no, okay, because they don't match. If it were both SAS, then that would match, and they would have to be congruent, but that's not necessarily true because those triangles could be different. All right, the last thing is, are the following pairs of triangles congruent? The only thing that's different with this is you have to write your congruence statement. I just wanted to practice that a little bit. So I know X is congruent to X. I know DC is congruent to CN. And I also know that angle E is congruent to angle M. Okay, and so this is going to be angle, angle, side. So the criteria is angle, angle, side. This is a way to prove congruence. I write my congruence statement, so I'm going to say it's going to be triangle E, let's say EDC. It doesn't have to be EDC. You can rearrange your letters. But once you write that, you have to write your corresponding. So E right here is green, and I know it's congruent to M, so I know it's going to be triangle M. And then we also, so then we have D. Well, D is right here, and N and D are congruent, so this has to be M, N, and then C. So M, N, C, it has to be those. This one here, this angle is congruent to this angle. This side is congruent to this side. And this side they share, and so this would be yes, this would be side, angle, side. And so I'm going to say, let's say triangle DEC. Well, if I go from D to E, that's where my little circle is, to C. So I know my little middle letter has to be a C. And then it went from D to E. And so what is equivalent, or what's congruent, TC is congruent to DE. So it's going to be TCE. Ooh. And then this last one, I only have two things. And so I have those angles, and so this is going to be no, there are only two things congruent to, I shouldn't write things.